Okay, I'm going to go over this review for the Unit 6 test. So number 1 through 5 says solve each proportion. So we're going to cross multiply. We're going to multiply across here and across here. So that's 8m equals 3 times 4, which is 12. And 8 goes into 12 1.5 times. Then we have, again, going to cross multiply. So we're going to do 5 times x plus 7. Set that equal to 2 times 10, which is 20. This is going to be 5x plus 35 equals 20. We're going to subtract 35 from both sides, so that's 5x equals negative 15. So x equals negative 3. Number 3, cross multiply again. So we're going to have 6n, and we're going to have that equals 9 times n plus 11. 6n equals 9n plus 99. We're going to subtract, again, I'm going to subtract the 9n from the 6n. That's going to give me 3n. And that's negative 3n, sorry, equals 99. And negative 3 goes into 99 and equals negative 33 times. Number 4, again, cross multiply. So we're going to do 10 times x minus 2. And that equals 2 times x plus 6. This is going to be 10x minus 20 equals 2x plus 12. Subtract 2x from both sides. That gives me 8x over here. Add 20 to both sides. That gives me 32. Divide both sides by 8. X equals 4. Number 5. Again, we're going to cross multiply. So we're going to do 11 times x plus 4, and that set that equal to 4 times x plus 7. That's going to give me 11x plus 44 equals 4x plus 28. Going to subtract the 4x from both sides. That gives me 7x. Going to subtract the 44 from the 28. That gives me a negative 16. And so x is equal to negative 16 divided by 7. Or we could say negative 2.3. Either one of those is correct. So for number 6, we're going to look at these parts. We're going to say UB over, that's UB right there, over DB. So that's little over big. There's DB. Sorry, B. UB over DB. Let me write that again. UB over DB is equal to little over big again. So that's going to be TB over CB. Now I'm just going to substitute numbers in for this. That's going to be 7 over 14. That equals 4 over CB. We're just going to cross multiply. So that's going to be 7CB is equal to 4 times 14, which is 56. And 7 goes into 56 8 times. So CB is equal to 8. Again, when we do this problem, we're talking about a little triangle over a big triangle. That's how we did that problem. Number 7. On number 7, it says that EDF is similar to RQS and defined SR. So on this, we're going to use our similarity statement to set up our problem. So SR is what we're looking for. So we're going to put SR, and SR, if you notice here, SR maps to FE. So we're going to put that over FE. We're going to set that equal to RQ, which we have right here, RQ, and RQ maps, see RQ right there, it maps with ED. So we're going to put it over ED. So this is going to be SR over 11 equals 48 over 8. I'm going to cross multiply again. It's going to be 8SR is equal to 11 times 48, which is 528. And they're going to divide both those sides by 8. So SR equals 66. So 8 and 9 say solve for x. The triangles are similar. Use the similarity statements to set up the problems. So Again, with number 8, we're going to look at TU. If you look at TU right here, and we're going to put it over AB. First two letters, so we got TU over AB, and that is equal to UV. UV are our second two letters in BC, so UV and BC. So that's 70 over 112, and that equals 4x plus 7 over 56. We're going to cross multiply these, so we get 112 times 4x plus 7, and that's equal to 70 times 56, which is 3,920. Then we're going to distribute this, and 112 times 4x is 448x, and 112 times 7 is 784. That's still equal to 3,920. We're going to subtract the 784 from both sides, so that gives us 448x equals 3136. Then we're going to divide both sides by 448, so x is equal to 7 here. Number 9, again, we're going to use our similarity statement to set up this problem. So we have that dB is similar to QS. So dB over QS, that's going to be equal to CB over RS. Now we're going to throw some numbers in here. So now we have 25 over 2x minus 6, and that's equal to 30 over 12. Going to cross multiply here. So that's going to be 30 times 2x minus 6, and that's equal to 25 times 12. So that's going to be 300. Wait, this is 300 over here, sorry. This is going to be 60x minus 180. 60x minus 180. Going to add 180 to both sides, so that's going to be 60x equals 480. And 60 goes into 480 8 times, so x is equal to 8. 10 says, are the following polygons similar? Are the rectangles similar? If so, what is the similarity ratio? And then are the triangles similar? If so, what's the similarity ratio? Okay, so it says, are the rectangles similar? So when we talk about similarity here, we're going to compare the side of 2 here and the side of 4 there. So 2 over 4. And then we're going to compare the side of 4 here and 1, 2, 3, 4, 5, 6, 7, 8. 8. 4 over 8. So the question is, are those ratios equal? And 2 over 4 is equal to 1/2, and so is 4 over 8. So we know that those ratios are the same. So are the rectangles similar? The answer is yes. So then it asks us if the triangles are similar. So here we have a base on this one of 2 and a base of 1 here. So I'm actually going to go smaller over larger, so that's 1/2. And for the height here, we have 3 and we have 3 here. Wait, 1, 2, 3, 4. Sorry, that was 4. So over here, we have a height of 4, 1, 2, 3, 4. And here we have a height of 3. So that would be 3 over 4. Those are not equal. That means that the triangles are not similar because they do not produce the same ratio for the sides. Number 11 says, find the scale factor of the dilated triangle. So here, we're always going to take the ending numbers over the beginning numbers. So if we just take these two numbers right here, we could say 3 over 6. We know that that equals 1/2. Here, you can see 1 over 2 equals 1/2. 4 over 8. You could pick any number in these problems to figure out what the ratio is. And so it says, find the scale factor of the dilated. So the scale factor is 1/2 when we take the ending over the beginning. So this next set of problems says, find the missing length indicated. So on number 12, one of the things we need to notice is that we have a line inside the triangle and then a side of the triangle that are parallel. That means that we have ratios that are automatically set up. The first thing I'm going to do is find this part right here. And to do that, I'm going to subtract 4 from 12. That means that part right there is 8. Then I'm going to go ahead and set up my problem as a ratio of 4 over 8 is equal to 2x minus 8 over 12. Going to cross multiply here. 8 times 2x minus 8 equals 4 times 12 is 48. This is going to be 16x minus 64 is equal to 48. So I'm going to add 64 to the 48, and that's going to get me 16x equals 112. And 16 goes into 12 7 times, so x is equal to 7 here. So number 13. Again, I'm going to solve for this missing part right here, and 21 minus 6 is 15. So I'm going to do that first. Then I'm going to set up the problem. That would be 10 over question mark equals 6 over 15. I'm going to cross multiply, so that's 6 question mark equals 150. And then I'm dividing 6 into 150, so question mark is equal to 25. Number 14, this time we have 3 parallel lines. And again, I'm going to solve for this missing part right here. And to get that, I'm going to subtract 5 from 8, and that gives me 3 here. Now that enables me to set this up exactly the way it looks on the board. 5 over 3 is equal to 10 over x plus 2. I'm going to cross multiply 5 times x plus 2. Set that equal to 3 times 10, which is 30. That's 5x plus 10 equals 30. I'm going to subtract 10 from both sides, so that's 5x equals 20. So x here is equal to 4. So with number 15, it says find question mark again. Now these problems are a little bit different. I need you guys to notice that this angle and this angle are congruent. That means that the two triangles are proportional. So with this one, number 15, we're going to say, I'm going to set it up exactly the way we can see it here. So I'm going to say 14 over 8 is equal to 28 over question mark. Again, going to cross multiply, so that's 14 question mark is equal to 28 times 8, which is 224. Then I'm going to divide both sides by 14, so question mark is equal to 16. On these types of problems, we need to remember that we got a triangle here, and we have another triangle here. So we're looking at relationships between those parts. So we got the bottom here and the bottom here. That's what the 4 and 8 is. And then we've got the side here relative to the side here. So those are the relationships that we're going to use to actually set up these types of problems. So over here on the right, we have another one. And I'm going to go ahead and find this missing part right here. And 12 minus 4 is 8. So now I'm going to use that to set up the problem. So I could say 8 over 4. Again, we got this side of that triangle versus this side. So 8 over 4. And then we've got the other sides, the opposite sides. And we're talking about the triangle on the left, which is the 8. So that's x plus 6. And then the triangle on the right, which is the 5. Again, I'm going to cross multiply here. So we've got 8 times 5 is equal to 4 times x plus 6. So this is 40 equals 4x plus 24. Going to subtract the 24 from both sides, so that gives us 16 over here. It's equal to 4x, so x is equal to 4 here. For 17, 18, and 19, it says state if the triangles in each pair are similar. If so, state how you know if they are similar and complete the similarity statement. So on this one, we do know that we have these angles right here, and we've got, I'm going to mark these with 4 arcs and 4 arcs, because we've got 1 arc down here, we've got 2 arcs up here, and we've got 3 arcs right there. The problem is we don't have any angles in this drawing that show us that they are congruent. And our first condition with respect to similarity is that we have to have at least 2 angles that are congruent to each other. So this one is not similar because we don't have enough information about angles. Number 18. Again, here we have 2 parallel lines, and we have that because we have arrows on them. These 2 triangles share an angle up here, and this angle over here, F and M, are congruent because they're corresponding angles. So we could say that these two triangles, DEF, and DEF is here, DEF right there, is similar to DLM, which is that top triangle, and they are similar by angle, angle, because we don't have any sides for this one. Number 19, let me scroll this up a little bit. Number 19 has, we have two triangles here too. We have this triangle right here, and then we have this bigger triangle out here. So, again, we're going to talk about the little triangle. We could say 11 over the whole side here. So that's our little triangle, and then our big triangle is 22. Down here, again, I see that this is 28 for the whole thing, and that part's 14. So we could say this is 14 as well. But that's not what we really need. We do need this part. So 14 over 28, little triangle over big triangle again. And that's 1/2 equals 1/2. So because the ratio is the same, we could say that they are similar. Now also we see that this side right here, this 7 and this 14 are the third side. So we could say 7 over 14, and that is also 1/2. So on this one, we could say TUV, and again, TUV is like that. We talk about TUV, the triangle that's similar with that is the triangle TED right there. Triangle TED. Now, honestly, these two triangles are similar by side, 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 because we had all three sides. Or you could notice that this angle right here is in both too. So it could also be side, angle, side. Either one of those will work for this particular triangle. Number 20 says, what additional information is required to know that the triangles are congruent because of HL? On this particular problem, we know that vertical angles are congruent, so we could say that this angle is also 90 degrees. And because we have RD here and DE, those are a leg. So the other part that we need are the hypotenuses, and hypotenuses are opposite. Yeah, if I could draw an arrow, that would be good. Opposite the right angles. So that means that we got to know that RS is congruent with EF. Then we're talking about number 21. What must be true in order for ABC to be congruent to EDC by side, angle, side? So, first of all, we know that these two angles are congruent, and it says side, angle, side, so we have a side here, and we have a side there, and then we have the angle. So we need another pair of sides to be able to say that these two things are congruent by side, angle, side. So again, we could use our similarity statement. So we have AC, and AC maps to EC, sorry. So that is how we could say that the extra part is congruent with the extra part. So for number 22, it says the polygon Q32, R65, and S62 undergoes the transformation XY of 4X, 4Y. Name the coordinates of the image points and state the transformation. And then it asks us if the figures are congruent. So first of all, 4x, 4y means that we're going to multiply every point by 4. So that means that we're going to multiply 2 by 4. So that's going to be, Q prime is going to be 3 times 4. And 2 times 4. So that's going to be, Q prime is going to be 12, 8. R is 6, 5. So we're going to go R prime is going to be 6 times 4 and 5 times 4. So R prime is going to be 24, 20. And S is 6, 2. So again, we're going to multiply both of these by 4. So S prime is going to be 6 times 4. And 2 times 4. So S prime is going to be 24, 8. Then it asks us, are they congruent? No, because one is 4 times the size of the other. So the answer is no, they're not congruent. And it asks us what's happening. It was a dilation. by a scale factor of 4. 23 says, given that angle B and E and C and F are congruent, what other piece of information is needed to show that ABC is congruent to DEF? So I'm going to draw an ABC, and these doesn't really matter what these look like, and a DEF. And then I'm going to mark on them what we know. So we know that B is congruent to E, and we know that C is congruent to F. Now it says that these have to be congruent by angle, side, angle. So if you notice, we have an angle and then a side between the angles and an angle. So this is the side that we're looking for here. That would be BC is congruent to EF. Number 24 says, what additional information is required in order to know that the triangles are congruent because of angle, angle, side? Now this time we have a side and an angle, so we need another angle next to the angle that was given. Here again, we need another angle next to the angle that was given. So this is now angle, angle, side, and angle, angle, side. So that would mean we needed angle L to be congruent with angle S. So this one says to find the measure of KLN. KLN is this angle out here. And to do this, we're going to add this angle plus this angle and set it equal to this angle. So we're going to say 9x plus 16 plus 6x plus 15. We're going to set that equal to 19x plus 3. So 9 and 6 are 15, so that's 15x. And then when we add 16 to 15, that's 31. That's equal to 19x plus 3. We're going to subtract 15x from 19x. That gives us 4x over here. And we're going to subtract 3 from 31, and that gives us 28 over here. And 4 goes into 28 7 times. So x is 7. Now we have to plug that x back in to this angle right here. So that means we're going to plug it back into the equation 19x plus 3. So that's going to be 19 times 7 plus 3. And that equals 136 degrees. If we want to check this, we can put this 7 back up in this here, and then add those two parts together to see if they actually equal 136.